Okay, welcome to Chapter 5. We're going to start Systems of Linear Equations, and the first lesson is going to be about graphing. So what we're going to first check our solutions, then we're going to solve by graphing and apply them to real life. So when we have a system of linear equations, it's a set of two or more linear equations in the same variables. So here's two equations, okay? The solution is an ordered pair that is a solution for both equations. So remember when we put a line on a graph, there are infinitely many solutions possible, and there has to be, or there should be, if there is a solution, one place where those two lines will intersect, and this will be that point or that solution. So I'm going to go ahead and skip this and go right to this step right here. In this first example, this is on page 135 out of your student journal, we want to check to see if this is a solution to this system. And how we do that is through substitution. Every x and every y. So we'll just substitute those in. So we would take 3 plus 1 and check to see that it's equal to 4, which it is. And then we would take 2 times 3 minus 1 and see if that is equal to 3. Well, 6 minus 1 is 5, not 3. Therefore, it is not a solution for the second line, which means that this is not a solution for these. So no. To tell whether they are a solution, no. Okay? Why don't you go ahead and try number 2. Pause the video and answer the question on Edpuzzle, and I will continue ahead with number 3. So we'll check this one. So here's our x, here's our y. So now this time the equations are set up in slope-intercept form, but we can still substitute in a 0 for y and make that equal to 2 minus 2 by substituting in the 2 for the x. And since 2 minus 2 is 0, I know mentally that that does work. Looking at the next one, we have 0 for y, and then we would have a negative 3 times 2 plus 6. So we have negative 6 plus 6, which also equals 0, and it works for this as well. So the second one is a yes. Okay. All right. So next, we're going to examine the graphs and double check to see what the solution is and estimate the point of intersection. And then we will check the work. So let's see what that looks like. Right here on problem number 7, use the graph to solve the system. So we want to see, where do these two lines intersect right here? It looks like they intersect at the ordered pair 2, negative 2. All right, so we will do the step where we check to see that it is true. So 3 times 2 minus 2 times negative 2 has to be equal to 10. So we'll get 6, and then when you have a negative 2 times 2, it's a positive 4. And that works for the first solution, or first equation. Let's see if it works for the second. Is 2 plus negative 2 equal to 0? Yes, so it does. So we know that this is a solution. So go ahead and do number 8. Pause the video, work out number 8, see if you can come up with the correct solution for this system, and I will continue on to number 9. I see that in number 9, they intersect right here, and that ordered pair is 4, 2. So 4, 2 is what I think the solution is. Let's see if it actually is. So checking your work is actually a pretty important thing, especially with graphing. All right. So we'll have 4 plus 4 equal to 8. It works for the first equation. Is 3 times 4 minus 2 times 2 equal to 8. And we have 12 minus 4 equal to 8, and it works for the second. All right. Now we are going to graph. So we can graph using the slope-intercept method. We'll have a point at the y-intercept, which is 3. And then we can use our slope, which is negative 1. So down 1 over 1, right? We could do a couple of these, especially when I do it on a graph like this. The other thing is we can go up 1 and back 1. Remember, a positive rise and a negative run would also give us a negative slope. I have such a hard time drawing on there. All right, the next one is at, let's change the color here. Positive 5 is our y-intercept, and it's a positive 1, so up 1 over 1, which means we can also go down and back. So we can see right here where the two lines intersect, and we can estimate that to be our solution of -1 and 4. So we want to double check it. Is 4 equal to the opposite of -1, which is 1 plus 3? Yes. Is 4 equal to -1 plus 5? Yes. So we checked our work that we do have an actual solution. I apologize that this is so sloppy. -1 and 4. That comma almost looked like a 1 there. So go ahead and pause the video, and I would like for you to work out number 11 in your student journal and come up with a solution, and I will continue on with number 12. One thing you can do is you can always, for me personally, looking at 3, 2, and 6, I can say, ooh, I'm going to just solve with intercepts. So when I'm solving for my x-intercept, I know that I'm solving 3x equals 6. So x is going to be equal to 2, and that's where I'll put the point. And when I have -2y is equal to 6, I have y equal to -3. So I could come down here on the y at -3. And so my first line was very easily graphed by using the x and the y intercept because it was in standard form and all the numbers were evenly distributed. Then I have my second line here. Y is equal to -3 is a horizontal line. Ooh, that is straight. We're going to draw everything with a ruler. So we can see that the point of intersection is right there, and that is at the ordered pair 0, -3. So we want to test it out to make sure. So 3 times 0 minus 2 times the -3 would have to be equal to 6. So 6 equals 6 is true. And then we have -3 equals -3. And that's also true. So notice that we didn't have an x to substitute in right there because the coefficient of x was also 0. The slope is 0 on this horizontal line. So since it works, we know that that's our answer. All right, and finally, our last one. We're going to have to write the system of equations on this one and then solve it by graphing. And this is why we'll see in this example why we want to do the next lesson, which is probably substitution or elimination. All right, so we're going to have a test. We have a test with 20 questions, and it's worth 100 points. We have a lot of information here. We know we have 20 questions. We know we have 100 points. It has X true and false questions, and they're 4 points. Y multiple choice, and they're 8 points. So we know that X is equal to our true false questions, and Y is equal to our multiple choice. So now we're going to write some equations here. We know that the number of true false plus the number of multiple choice is a total of 20. So X plus Y is equal to 20. But we also have information about the points. You can see that the total test is 100 points, and that the questions that are true and false are worth 4 points, and the ones that are multiple choice are worth 8 points. So if we took 4 times the number of true and false, and then 8 times the number that is multiple choice, we would get a total of 100 points. So we need to graph these. So one thing we can do is pretty easily, the first one can be easily solved for y. So we'll rewrite it and we'll say we're going to subtract x from both sides. So y is equal to -x plus 20. And we could graph this because we can go all the way up to 20, which is our y-intercept. And then down 1 over 1. So we basically would have down 1 over 1 is, and I'm sorry that I'm gonna make all of these little dots, and the reason I am is because I'm doing it online. You should be able to put a ruler on your paper and connect the dots. And I know that the graph that I'm using is a little different than the graph that they gave you in your book, and I apologize for that. I just couldn't quite make mine work. All right. I have to try. Not great. All right. Then, if I did the other equation, I'm going to go ahead and use my intercepts. I know that 4 is divisible, so I can get my x-intercept pretty easily and say, okay, x is going to be equal to 25, which is not even on the graph. This one's not going to be so easy because it's not divisible, but the other way would be solving for y, which would give me a decimal y-intercept anyway. So why not, right? My y-intercept is 12.5. So that's why I used this graph. It was a little easier to get to 12.5. So that's going to be halfway here between the two. Then if I were to continue on and have 1, 2, maybe this 25 would be right here. I don't know how I'm going to draw this without a ruler. I did my best. All right. So it looks to be that they are intersecting at about right here, which is a 15 for my x and a 5 for my y. And what that means, or the implications for this problem, is that I would have 15 true false and 5 multiple choice. Does that work in both of these? Well, we know that 15 plus 5 is 20, and 15 times 4 is 60, and 5 times 8 is 40, and 60 and 40 equals 100, so it would actually work in this case. But as you can see, graphing with decimals is not always the most easiest thing to do, and a lot of times we have to estimate that solution. So in the next few days to come, we're going to learn some easier ways in my book to solve a system of equations.